In this section, we're going to talk about circle graphs. So this really could have gone in the first section where we were talking ways to visually represent data. So we looked at pictographs, we looked at bar graphs, line graphs, and histograms. Circle graphs are similar in the sense that it's just a way to represent data that you've collected. Okay? So the definition here is a circle graph, also known as a pie chart, is a type of data visualization that displays data as slices of a circular pie. Okay? Now, you do end up using percentages when you have a circle graph, so that's probably why we kind of treat it differently or like as its own section in our book. Okay? But let's talk about some important things. So you basically take your circle and you break it into little triangular looking pieces, all for each item in your data set. Okay. So each sector of the circle represents a specific category or segment of the data. So you have these sectors of your circle, you just break it into these little triangular pizza slices. Okay. And each pizza slice represents one of your categories. Okay. Now, the grand total of all of your pizza slices has to be kind of like 100% of whatever you're looking at. So, a really classic example is people might look at their monthly budget, okay? And they're like, okay, our monthly budget is this entire circle. Everything we spend is this entire circle, but then you break that circle into where your money's going. So, you're going to have money go towards things like rent, groceries, utilities, maybe your car, maybe savings, maybe entertainment. So you're going to break your monthly budget or your annual budget, whatever, into different pieces of where your money goes each month. Okay. And the size of the sector, the size of the pizza slice represents the size of whatever that segment or that category is. So let's say budget again. Most of us, the majority of our budget goes towards rent. So maybe rent is going to be the largest pizza slice, and then maybe entertainment is going to be the smallest pizza slice. But the size of the pizza slice or the pie slice is going to correspond to how much, what percentage of your budget goes towards each of those categories. Okay. So the size of the pie slice really does matter. Okay. So again, we have each sector of the circle represents a specific category or segment of the data. Each sector of the circle represents a portion of the whole data set. So the size of the pizza slice matters, okay? The size of the sector of the circle is proportional to the data value it represents. So if 40% of your monthly budget goes to rent, then you're going to have a pizza slice that's 40% of your whole circle, okay? Or a pie slice, whatever you want to call it, okay? The whole circle represents 100%. So the whole circle is 100% of whatever the overall category is. So if we're talking budget, the whole circle represents 100% of your budget, and the little pie slices have to add up to that, okay? Some advantages. It's very useful for making comparisons between categories visually. So, like when you have your pie chart or your circle graph, you can see really clearly what you spend, like if we're talking budget again, what you spend the most on, what you spend the least on. Okay. You can also label things. So, when you have your circle graph, each pie chart is generally going to be labeled with whatever its category is, and then oftentimes either a number or a percentage. Okay, so you get like a lot of information from your pie chart just kind of at a glance. Okay, disadvantages. This is not going to be something you want to use where you have loads and loads and loads of categories. Okay, you've got to split this circle into segments. So you don't want like 20 segments to your circle. Otherwise, they're all going to be so small that they're visually insignificant. Okay, so this is going to work really great when you have like maybe 7 or 8 total categories. Okay, because otherwise your little pizza slices or pie slices, they get so small and so insignificant that you can no longer make those nice visuals. So you are somewhat limited into the categories that you can have. And then the graph becomes, it just becomes too difficult to read if you have like too many categories. Okay. So again, you're limited a bit here. Okay. So let's go ahead and look at an example, and I'll be darned. Look at that. We're going to look at a budget. Okay. This is kind of like a classic example of how circle graphs are used, okay? So the following circle graph represents the monthly budget for the Valdez family, okay? So you can see they've got it titled monthly budget. You can see the little circle graph, but then there's a key that goes with this circle graph, okay? So instead of labeling each individual pie piece, they've just made a key to kind of represent what each pie piece is depicting. Okay, so here we have that yellow is rent, and just like we kind of predicted earlier, rent is what most of us spend the most on each month. So yellow is rent. Okay, The light blue is utility or utilities. Dark blue is transportation. Green is miscellaneous. Purple is charitable contributions. And red is food. Okay. So the first thing I want to do is I want to just figure out how much is their total monthly budget. Okay. So part A says, what is the total monthly budget for the Valdez family? You kind of need that information right off the bat. Okay. So we know that we're going to start with yellow. We're going to go down this list right here. We have 1,000 plus 300 plus 650 plus 600 plus 100 plus 250. I want to know how the Valdez family gets by with spending only $250 on groceries. That's magical to me. And 1,000 on rent too. Good grief. Okay, so let's add them up. I'm just going to use my handheld calculator instead of switching calculator screens because I'll for sure forget every single one of these numbers by the time I switch screens. So if you haven't gotten your calculator out, pause the video, get your calculator out, and then let's go. So we have 1,000 plus 300 plus 650 plus 600 plus 100 plus 250. So it looks like the monthly budget for the Valdez family was 2,900. So that's the total monthly budget that they're working with. Okay. Now we need to answer questions based on this. So for part B, it says, what is the ratio of the total spent on rent and utilities compared to the total budget? Okay. So the first thing we want to look at is rent plus utilities. We want to know the total for just those two. Well, rent was 1,000, utilities was 300, so the total for rent and utilities is 1,300. Okay, now we know the total budget. Okay, the total budget is 2,900, and we're looking for a ratio. So, what ratio do we have? And we want to make sure it is reduced. So, we want the ratio for rent and utilities compared to the total budget. So, 1,300 over 2,900. Okay. Now, as far as reducing this goes, you could certainly reduce this by hand. You could use a calculator. I'm not going to get too picky as long as you show me kind of what you tell your calculator to do, but there is a shortcut here. When you have numbers that end in zeros, you can cancel just zeros. It's like dividing by 10. So for each zero in the top, you can cancel a zero in the bottom. So I've got a zero in the top, I've got a zero in the bottom. That's basically like dividing by 10. Okay. I've got another zero in the top and I've got another zero in the bottom. That's like dividing by 10 again. Okay. So what we're left with is 13 over 29. These are both prime. We're reduced. So the ratio of rent and utilities compared to the total budget is 13 to 29. So for every $13 spent on rent and utilities, $29 is going to towards the whole budget. Okay. Now, finally, I think this is the last part for this one. Yeah. Nope, we've got two parts. There's a hidden part. Okay, so what is the ratio of money spent towards utilities compared to just transportation? So utilities is 300. Transportation is 650. Okay, so we want to write a ratio and we then want to reduce it. So we're looking at utilities compared to transportation. So utilities on top, transportation on the bottom. And again, we can do the whole like cancel a zero. There's a zero in the bottom, there's a zero in the top. We can cancel one each. So that's basically just a quick way to divide by 10. So then we're comparing 30 to 65. And if numbers end in 0 or 5, they're divisible by 5. So these are both divisible by 5. Let's see what we get. So 30 divided by 5 is 6. 65 divided by 5, you may need to do a little side work or you can use your calculator, but 65 divided by 5 is 13. So the final ratio is 6 to 13. Okay, so that means for every $6 we spend on utilities, we need to spend 13 on transportation. Okay, and then finally, one more little part hidden down here. Let's make sure we can see everything. What percentage of the monthly budget is spent on rent? So rent is $1,000. So I'm gonna have to scroll down now. So rent is 1,000. Total budget was 2,900. We already found that out. And we want to know what percentage of the total monthly budget is the rent. Okay. So the total monthly budget is going to be our base, and then the rent is going to be our amount. And if memory serves me, we need to do the equation maybe, because I feel like I did Let's just do the equation because I'm thinking about a previous video. So let's do the percent equation. So the percent equation is amount equals base times percent. Okay, so we fill in the amount and the base, and then we need to solve for the percent. So we're going to get 1,000 equals 2,900 times percent. Now remember, when you use the percent equation, you input the percent as a decimal, and then when you solve for the percent, it gives you a decimal that then has to be converted to, it gives you a decimal, you then have to convert it to a percent. So do keep in mind, we're gonna have to play around with our answer in just a bit. Now, I want to get the p alone here. To undo the multiplication of 2,900 and p, I divide by 2,900, and I have to do that on both sides. 2,900 divided by itself is just 1, so that gives me p equals 1,000 divided by 2,900. So we're going to go to the calculator for this one. So, ooh, is it here maybe? Yes. Okay, so we need to take 1,000 and divide it by 2,900. So 2,900, whoa. And remember, it's going to give us a decimal version. We need to convert this to a percent. So essentially what we do to convert this to a percent is we just multiply it by 100. So let's multiply it here. So multiply by 100, that moves our decimal to the right twice. So we're looking at 34.48. Now let's say we round this to one decimal place. So we're looking at this second four, the first four after the decimal. Directly to the right of that, we have an 8, which tells me to round up. So the 4 after the decimal becomes a 5. Everything after that gets chopped off. So we're going to say approximately 34.5. So this is approximately 34.5% of the budget goes to rent. And that kind of makes sense if you think about the whole budget. Our whole budget was not quite $3,000 a month, and 1,000 of it goes to rent, so that's about a third. So it makes sense that our percentage here would be a little over 33%. Okay, so that's a really, really super basic circle graph and how you can pull some information from it. Okay, let's go ahead and look at one more example, and then we'll call this section done. Okay, so it says use the provided circle graph to answer the following questions, and we have a little bit of information about our circle graph. So we're told that the following circle graph depicts the percentage of each type of vehicle sold at a group of dealerships last year. There was a total of 15,000 vehicles sold. So we know the grand total here is 15,000 vehicles. What's a little bit different about this one is look at this key here. So again, instead of labeling the individual circle graph, which they'll sometimes do, they just gave us a key here so it doesn't get so jumbled. So we have it broken down by color, okay? So you can see that the dark blue represents four-door sedans, and 43% of the total vehicles were four-door sedans. The green is SUVs, which is 21% of the total cars sold. White is minivans, red station wagons, and then the light blue is the two-door coupes, okay? So in this one, they give you a total number of vehicles sold, and then they tell you the percentage of each of these. So let's just add the percentages and make sure everything adds up to 100. So we've got 43 plus 21 plus 9 plus 6 plus 21. And let's make sure that adds up to 100. So 43, I'm just going to use my handheld again. 43 plus 21 plus 9 plus 6 plus 21 is 100, so everything's good there. So we can see that the percentages here, they really add up to 100, and we know the total cars is really 15,000, okay? So let's answer the questions. Part A says, how many of the 15,000 vehicles sold were SUVs? Well, the 15,000 vehicles sold, that's our base. That's the entire quantity being considered. The SUVs we know is 21%. Okay? So we need to know what number, like what physical number of the vehicles were the SUVs. Okay? So what we have to do is we have to figure out the amount. We know the percentage, we know the base, we don't know the amount. Okay? And the amount is the actual number of SUVs, not the percentage. Okay? So we have the amount over the base equals the percent over 100. I'm going to try to always split the percentage method or the proportion method and the equation method. So in the last example, we did the equation. So for this one, I'm going to do the proportion. Okay. So let's see, we don't know what the amount is. We know what we're looking for, but we don't know how many physical cars were SUVs. We do know the base. It's the total number of cars. And we know the percentage is 21. We do not have to convert it to a decimal because we're putting it over 100, which converts it to a fraction, which is what we need. Okay? So we then cross multiply, and I always multiply the diagonal that contains the variable first. So I get 100A equals 15,000 times 21. So if you don't have your calculator out yet, get your calculator. We're going to do 15,000 times 21, which is 315,000. All right. Now I need to divide both sides by 100. That's going to get the A by itself. So 100 divided by 100 is 1. 1 times A is A. And then as far as the 315,000 divided by 100, you could certainly go to your calculator here. No judgment. But remember, if numbers end in 0, you can cancel 1 0 top and bottom. So I've got a 0 in the top and bottom that I can cancel. I have another 0 in the top and bottom that I could cancel. So what this gives me is 3,150 over 1, which is really just 3,150 of the cars were SUVs. Okay. So we have to do a little bit more work here. So in the previous example, when we were talking about the budget, we knew the dollar amount for each of the different categories, and we didn't know the percentages. Here, we know the percentages. We don't know the individual number for each type of car sold. Okay. Now, what is the ratio of minivans sold to station wagons sold? So we can do this two ways. We could just take the percentages and write them as a ratio and then simplify. Or we could do the work. So for this one, just to kind of prove things work a certain way, I'm going to do it both ways. Okay, so we're going to do it the easy way. We're going to write our ratio of minivans to station wagons. So we know minivans were 9%, station wagons were 6%. So I'm going to write 9% to 6%. They're both divisible by 3. So I get 3 to 2. So that means for every 3 minivans sold, there were 2 station wagons sold. Okay. Now, the other way you could do this is to find the actual number of vehicles sold. So we're going to do this kind of quick just for the sake of like practice. So don't get too bent out of shape here. I'm going to do the percent equation for both of these just because it's quick. So the amount of, let's do minivans first. The amount of minivans, well, it's going to be 15,000 because that's the total number of vehicles times whatever percentage we have for minivans, which is 9%. So I'm going to take 15,000, multiply it by 0.09, and we get that there were 1,350 minivans sold. Now we want to do the same thing for station wagons. So we don't know how many station wagons, but we do know the total number of cars, and we know the percentage. So 15,000 times 6% is 900. Let me shorten these lines so I have a little bit more room. Okay, so now what we're doing is we're looking at minivans compared to SUVs, or not SUVs, station wagons. Okay, we can go ahead and cancel 1 0 top and bottom. So we've got 135 over 90. Well, they're at least divisible by 5. So let's see, 135 divided by 5 is 27. 90 divided by 5 is 18. Well, they're still divisible. 27 and 18 are divisible by 9. So we can divide them both by 9 and we get 3 to 2. Okay. Either way you slice it, you're going to get a ratio of 3 to 2. So that means for every 3 minivans sold, 2 station wagons were sold. This one right here is for sure going to be the easiest. We started with the percentages and then just simplified it. However, if you didn't see that, you could go ahead and do all the work. You're going to get the same answer at the end of the day. Okay. If you're looking to save some time, do it the first way I showed you. Okay. So Part C says how many more sedans were sold than SUVs? So we can do this one a couple of ways too. Let's go ahead and start by figuring out how many SUVs and how many sedans were sold. Now, SUVs, we know. We already found the number of SUVs in Part A. We found that there were 3,150 SUVs. Okay, so 3,150. 150 SUVs. Let's figure out the sedans. So for the sedans, the number of sedans is the amount, okay? We don't know the amount, but we do know that there's 15,000 cars sold total. And the the four-door sedans, that represents 43% of the total cars sold. So we're going to take A over 15,000 and we're going to set it equal to 43 over 100. I'm going to do the proportion here just to be fair so that everybody, whoever likes whichever method, everybody gets to see them both. So we get 100A equals, well, I need to take 15,000 and multiply it by 43. So that's 645,000. We divide both sides by 100, and we get A is 6,450 sedans. Okay, so the question was how many more sedans were sold than SUVs? So we would take 6,450, subtract 3,150, and let's see, 6,450 minus 3,150, we get 3,300 more sedans. Okay, now there is another way you could do this. You could take the percentages. Okay, so we know that we had 43% for sedans, we had 21% for SUVs, so we could take 43 minus 21, so that's going to be 22% more sedans. And then you could take your 15,000, multiply it by 22%, and we get 3,300. Okay, so this is your shortcut method here. So the way that you would probably logically do this is we already know how many sedans we had. That was 3,150. We found that from part A. Okay, so we can put from part A. We then found the number of sedans sold, which was 6,430 or 6,450, excuse me. And then we just subtracted and we found the difference. The difference was 3,300 more sedans were sold than SUVs. Okay. The other way you could do this is take the difference in the two percentages. This is a little risky depending on your data set, but take the differences in the two percentages and then use that. So we found that the difference in the percentages was 22%. Figure out what 22% of the total number of cars sold was, and that represents how many more sedans we had than SUVs. Okay. Finally, it says how many of the vehicles sold were not station wagons or two-door coupes. Okay. So let's figure out station wagons plus two-door. Well, we had 6% station wagons plus 21% coupes. So we're looking at 27% of the cars were station wagons and coupes. Now, if we take 100% of the cars and we subtract 27, that gives us 73% were everything else. All right, so we can go ahead and we're going to do the shortcut method here. So we're doing kind of like this shortcut that I showed you in part C. Okay, so we can go ahead and take 73% of the total cars sold, which was 15,000. So let's go back to the percent proportion. So we don't know how many cars we're talking about for cars that are not station wagons and two doors. So that's going to be some percentage of 15,000. Now we know all of the other cars represent 73% of the total cars sold. So we're going to do 73 over 100. We cross multiply. So I get 100 times A. And then I need to multiply the diagonal 15,000 times 73, which is 1,095,000. Okay. And then I divide both sides by 100. 100 divided by itself is just 1, so I get 1 times A is A. And then we can knock off two zeros, one here and here, and then here and here. So we end up getting 10,950. So 10,950 of the cars were not station wagons or two-door coupes. Okay, so we did the shortcut method here. If you didn't want to do the shortcut method, you would figure out how many station wagons we sold. We would figure out how many two-door coupes we sold. We would add that up and then we would subtract that from 15,000. So if you want to see the long version of this one, you would say, okay, station wagons. Have we figured out how many station wagons were sold yet? I think we did it in part B. Yeah, so from part B, we know that we had 900 station wagons. Now, for the two-door coupes, we got to do a little work. Okay, we don't know how many two-door coupes were sold, so we're going to say that's the amount equals 15,000 times whatever percentage. And we have that two-door coupes represented 21% of the cars sold, so 0.21. And I'm just going to use my handheld here again. So 15,000 times 0.21 is 3,150. So we would take 900 plus 3,150, and we get 4,050. So 4,050 of the 15,000 cars were station wagons and two-door coupes. But the question was, how many were not those two types of cars? So we would take 15,000, subtract 4,050, and fingers crossed, I think my math is good, we're going to get 10,950. So 10,950 cars were not station wagons or two-door coupes. So you had two ways to go about this problem, just like we had two ways to go about the previous two problems, okay? So whichever one you prefer is really fine. You, the mathematician, need to be able to justify your work to your instructor. So remember, you have free reign with calculators, but the calculator is there to do your side work, not to do all of the work for you. So you still have to show us your setup. So all of the stuff you've seen me write out here for these four problems, that's the work that you need to show your instructor. You just let the calculator do those like little individual calculators. All right. So there you have it. That's circle graphs. They're really cool. I prefer the circle graphs that look like this, where you have your circle graph with all the colors, then you have a key beside it that gives you the information. To me, they're a bit easier to read. It is very common, though, to see a circle graph like what we have here, and then on each little pie piece, they'll have like what it represents and what percentage or what number goes along with that pie piece. Perfectly fine. Some people might like those too. I just find them a little bit harder to read, but that's a personal thing. All right. But with all that said, this is circle graphs.